There's another homework problem. I've already asked you this problem as I think somewhere along the line as a conceptual. It's kind of like an exam, kind of like the last exam actually. Two infinite currents, one of them coming toward you up here, one down here that's going away from you. And the question is to find the total magnetic field at point P. And so that's a situation where you can use Ampere's law. The current up at the top you draw an Ampere's loop around that of whatever radius this is, then that current produces a magnetic field. Since it's going out of the board, it goes in that direction. A magnetic field that you can calculate using Ampere's law, because that's the current enclosed to produce that field. And then separately, Ampere's law for this field, for this current, draw an Ampere's loop around that, and for that current, you end up, because of the right-hand rule, and that current is inward, you end up with a magnetic field that's in that direction. And so these two fields will partially cancel each other. They're both, one's to the right and up, one's to the right and down. The up and down parts will cancel, and you end up with something that points to the right at this point. And what you find is that B total is a function of x. This is the x-axis. And B total depends on how far away you are, because that's the only, well, also a function of the distance between them, 2a, but that's a constant. And so when x gets very, very large, if you just take the limit as x gets really, really large, I don't think I have time to work this out. If you just take the limit as x gets really, really large, you're going to find out that it goes to 0. Okay? That isn't what we're looking for in this kind of a problem. We're looking for how does it vary with x? Does it drop off linearly? Does it drop off as x? Or as, sorry, if it drops to 0, does it go like 1 over x? That drops to 0 when x goes to infinity. Or 1 over x squared, or 1 over x to, I don't know, some other power. May not be an integer at all, maybe a fraction. So that is, and maybe I'll say a little bit more about this in whatever I post. That's what we're looking for. Basically, you could think of this as a Taylor series expansion of whatever you calculate for b of x. Expansion in terms, well, however you can approximate this to find out how x changes with position. So let me leave it that way, and I'll probably write something out and give you a hint as to how to do that kind of thing. But that's what they're looking for there. How does B vary with x when x is large? So in that limit. And it can drop off in all sorts of ways.